Hello, everybody. Welcome to the monthly OSHWA show and tell. So the way we are doing this is after our incredible 24-hour extravaganza of fun, we've decided that it would also be fun to do just a monthly broadcast where we can pull on our latest certifications and see what people are making in the community and just really have some fun getting to know what else is out there and get to hear from folks about their projects almost immediately upon being certified. So we're really excited to start this new venture. I'm really excited to be able to hear about people's projects a little bit more up close and personal, especially since I am usually writing the certification roundups. So I really get curious about these projects. We've got 3 projects with us today. We're going to be looking at the Signet, the PicoReek, and the respiratory pressure and flow data collection device. Very fancy name. Academics, they love those big long names. And to get started today, we're going to actually bring on Adam, who is in charge of the Signet project. Hello, Adam. How are you doing today?
I'm doing great. Thanks.
Thank you so much for joining. So, you are working on the Signet project. How about, let's just get a little rundown of how this project came into your life.
Yeah, so that's actually a fairly interesting story. I got one of these Signet password manager devices on Crowd Supply like 5 years ago. And then I found out how bad a compromise is for software password managers. And I thought, you know what? I want another one of these things. And when I went to buy one, there was no one around. Like everything was gone. And so, but it's open source. So we all know anyone could just pick it up and do it. And I did. So I'm now the maintainer of the project. I've developed the latest version of the board. I maintain all the software, and now I have a second Signet device through a tremendous amount of time and effort. But it's been a good experience. I've been picking up more surface mount soldering skills. Like I never used KiCad before this, so this is all, I've been doing this for the last year or two now, but it's all fairly new skills in my life as things go. So yeah, the project's once more alive and well, and I'm making the little devices here in my home, my electronics workbench.
That's awesome. That's like a thing that always comes up with open source projects. I've seen it as a meme format thousands of times. So like people who want to make the project. Yeah. People who want to maintain the project. No. So maintainers are really our number one in the open source community. Having folks that want to take on a project and maintain like that is always such a gift. Yeah, do you want to tell us a little bit about the Signet itself and what it can do and what excites you about it?
Yeah, so it is a little hardware password manager. Looks like this. And it's a USB device. It's not a thumb drive. I get that question a lot. But it's a encrypted password manager. And so the way it works is you unlock it with your device passphrase, and then you can get the passwords out one at a time. And every time you get a password out, you have to press the button, which means that if your computer is compromised and you unlock your password manager, it's not going to just give up all of your passwords at the request of the computer. You would have to like sit here and press the button for every single password that you'd need the attacker to steal. And so that is the thing that I'm super excited about. It adds a layer of physical security to your password database. Aside from that, it's basically just your regular password database with higher security. It works on Windows, Linux, and Mac. And if there are any Android developers out there who want to contribute to the project, it used to work on Android, but then Android updated their stuff and won't let you install old APKs anymore. And I haven't been able to get it to compile, so opportunity for someone to jump in and help out with the project. So anyway, yeah, it's all encrypted. So if you lose it and someone else picks it up, they're not going to get all of your passwords just because they have physical access. And like I said, if someone gets digital access to the device, but not physical access, they can't hit the button to steal all your passwords. So that is really cool. And I can give you a little demo of how it works. Oh, right.
Yeah.
The other important part, it does actually, when you want to get a password out of it, it can switch into a keyboard, and then it will type the password, so it never has to hit the clipboard. So if you're worried about your system, some application monitoring your clipboard, just waiting for you to put copy a password on there, it can get around that, which is cool. It can also copy them to the clipboard if you want to do that, but you don't have to. And if you don't have to, I would say just make it be a keyboard. So I can give you a little live demo here.
Yeah, that'd be awesome.
Share my screen.
Yeah, I love the like physical aspect. I love that there's like an actual button.
Yeah, that's key. So here I am. I got my device plugged in. It's my demo device, so I'll have a password. And now it is blinking. So it's waiting for me to hit the password. And if I don't hit that, it's going to time out here. So I'll go ahead and hit the button. And now it's unlocked it and loaded up my password database. So I've got my little demo accounts here. The one I'm using here is just a bare circuit board because that's my little test device. But like I said, the normal ones have a case, and I'm actually working on a new case. It's a little more, it's longer, but it's slimmer. So I'm pretty proud of that. That's nice. And then, yeah, if you wanted to like use any of these accounts, you can go here, and this will open up oh, my right clicking isn't showing. Okay. Imagine there's a context menu there, and the first option is browse, and that will browse you to the site if the URL has been entered. There's a login option, which will type in your username, hit tab, type in your password, hit enter. So that's your typical thing. You can type in just the username or just the password, or copy them to the clipboard. I clicked open here to like take a look at this account, and now again it is blinking at me, telling me I need to click. And it's not going to show the other window, so that's fun with screen sharing in software. Yeah, so there is a little demo video on the site that shows all of this. So I guess you can check it out there on the Hacks Urbana project page. Sorry about that.
I mean, we never know what's going to happen in this kind of situation, you know.
Yep.
Always new systems.
Yep, and obviously the hardware is open source, the firmware is open source, the software, the client here is open source, and I've published the CAD designs for the case. And when I get the new one finished, I'll publish those as well, because I feel like everything should be open source.
We love that. We also agree that everything should be open source. So right now, one of the big things you're working on is this slimmer case. Are there other components that you're hoping to add or work on?
There is. Right now, it is USB-A only, and I plan on adding a USB-C port. Actually, I don't know how many prototypes within arm's reach here, but I have some working prototypes, and I had to switch from surface mount USB-C to through-hole because it turns out surface mount USB-C pins are really, really small, and I was just having too much trouble with getting those to solder reliably. When I put these together, like, even though I've done it dozens of times, about half of them work on the first try, and the other half requires some rework. And so switching to through-hole instead of surface mount is just going to make my life easier as one of the people who makes them. I'm also looking for hackerspaces to help make these, because right now I make them and I'll sell them to anyone in the US, but I don't really want to deal with international shipping and, you know, having someone pay $30 for shipping on a device that costs $45. And so what I think would be great is if we had a bunch of makerspaces and hackerspaces that would build these and, you know, distribute them locally. Because it doesn't need to be me building them. That's the point of open source. You don't have to rely on one person or one group. And so it would be great if we could have like Seabase in Germany, making these and distributing them and so on. And that's just kind of like aspirational at this point, but I plan on hitting up the makerspaces that I've been to around the world and trying to get them involved if they're interested.
Yeah, it's actually such a good way to go about it too. Yeah, especially, decentralized distribution is such a big thing right now too, trying to avoid unnecessary shipping costs. I mean, the environmental impacts of shipping something that you're like, well, it's this big, but I still have to put it on the truck with the other items, and that's gonna have impact. Yeah, I really like thinking about it in that way of trying to spread it out without you having to do all of the work to get it out there.
Yeah, sustainability is a big goal of mine just in life. But this project has been around for 5 years. I added support for x86 processors. So if you've got an old 32-bit computer, it will work with it. And I plan on continuing supporting those indefinitely. Like, I don't have a plan to make a new model and, abandon this one. I'm in it for the long haul.
That's amazing. That's always like the most exciting thing to hear of, like, yeah, taking on the custodial role of a project and being very committed to its full lifeline is so important. We really do see so many projects that just kind of disappear, or, it does something really cool, but then you don't actually get to use it for that long because someone just gets tired of it.
Yeah, and I understand that. That kind of my strategy here is I'm not adding tons of new features. It's stable. It does what it's supposed to do. It's reliable, and I'll fix bugs here and there. I'll update it so that it works with whatever the newest library is. But it's not going to be this, constantly adding new code, because adding new code adds more attack surface, and that's not what I want in a security device.
Yeah, no, that makes sense. Yeah, and actually, just a question overall about, like, what drives your interest in security specifically?
I've been a hacker for as long as I can remember. I kind of really got into it in about 2004 when I joined the DC 949 hacker crew. And then I got a job in security after that. But what really drives me is I want to know how things work. And I'll be like, before I knew anything about security, I would hear about people having their computers taken over. Like, oh, well, what happened? Well, like, oh, there was a bug in the code. I'm like, wait a minute. So there was a bug in the code, and oops, we accidentally gave control over your entire computer. Like, you dumped the entire database. Like, what kind of an error would you have to make to have that happen?
Significant.
And so, years later, I've realized one little out of bound memory access could be that tiny mistake. And yeah, that is kind of the result. So that kind of set me down the path of wanting to figure out how we can stop these things from happening, or mitigate them, or do anything to have a chance, because we've seen, like, over the last 20 years, security seems to kind of get worse in a lot of ways. And I want it to be simple, easy to use, and secure. And those things go together really well, because the more complicated it is, the more difficult it is to secure. And so kind of my drive of wanting to know how things work and, tinker with them, I think is really what brought me into the security world.
Yeah, definitely. That's pretty great. I mean, I personally am not the best at code, so I know that it's a good thing I'm not in charge of any larger projects where I would be making problems. I would be the one putting in the mistakes that make it that anyone can have access to the whole system.
And that's why we have code reviews.
Exactly. And beyond the Signet, do you have any other projects you're thinking about taking on in the future, or are you pretty focused on sticking with the Signet?
This is the main one. I actually made another device that I just got certified, which is it basically lets you use a USB keyboard on your computer's PS2 port. And for most people, they're like, why would you want to do that? You have USB ports. Why don't you just plug it in? And that's a fair point. And for most people, it doesn't make any sense. You just plug in your keyboard like a normal person. For me, I use Cube's OS, and I don't want to give USB keyboard access to DOM0, which is the privileged VM, basically. And so if you plug in a PS2 keyboard, you don't have to pass through that USB and give it special access to this privileged VM. So it's a security enhancement. And for a while, I was using an old keyboard that was PS2, but I'd like to use a modern keyboard. I have this nice split keyboard. It's great, but it's only available in USB, of course. And the little USB to PS2 adapters, they don't work anymore because they only work with the old keyboards that knew how to deal with them. And so you now need something that's active and, does the translation for you. So I built one of those and got it certified open source. I got a partner in crime on that one who did the code and the original prototyping. And I just made a board that made it easy so you don't have to solder anything. You just slap this board onto a Raspberry Pi Pico and you're good to go. So that's another project I could go on. And that's pretty much it for me. Plan on not overextending myself. I've made that mistake before with too many projects, and just focus on them. And if there's nothing to do on the project, then sure, I'll take on some more. But there's some bugs to fix, some rough edges. Like I said, getting the USB-C port added and the new case. So there's little things that I'm working on with the Signet, and if I get bored, maybe I'll take on some more projects, but that's not been a problem.
Yeah, no, that's actually such a smart thing to take on too. Like, I feel like a lot of people don't fully acknowledge the amount of devices that you're allowing them access to everything, but just by putting it into your USB port. So trying to find more ways to mitigate that access and kind of push back against this idea that these bigger tech companies should always have access to your whole system. I say this as I am on a Mac laptop.
Sure.
But it's provided by a job, so I have to use the things that I'm given. But yeah, these finding new and ways to just like really make sure that you're secure in what your system can do and what has access to it. It's going to be so important. It is important, and it's going to continue to get more and more important as people just keep giving away all their information to literally anybody who says accept all cookies. So these are some really, really rad projects, especially for those who are just getting interested in what it means to pay attention to the security of your system, because like something like the Signet, like that is very low barrier entry to getting that set up. There's so much, you have such good documentation and like really clear guide on how to utilize it. And I think that's going to be really, really important for a lot of people as they start to explore what it actually means to be secure.
Yeah, if it's not easy to use, people won't use it.
It's true. Thank you so much, Adam. Is there anything else you'd like to add on before we move on to our next speaker?
No, that's pretty much it. I'm excited to see what other projects we have going on here. Sounded interesting on the little advertisement.
Yeah, we've got some cool stuff today. Well, thank you again, and really looking forward to keeping up on what else you're up to, and I mean, seeing the Signet grow.
Thank you.
Okay, so that was wonderful. Adam is so cool. And also, I just love, okay, my cat is chewing on some plastic behind me, if you can hear that. I love people who have been doing various projects for years and years, and just, you can tell that they're deeply ingrained in that lifestyle. So next up, we've got Kelu coming on to give us some information about the Pico Rig, or actually Zero Rig. I mean, I keep calling it the Pico Rig.
Yeah, good afternoon, good evening. That's sort of one of the mistakes, because there are many mistakes that I've made with these projects, is giving them names that nobody can actually say, and no one knows how to name them. So the official name would be Picoric, but there is none actually.
Perfect. I do like saying it. It's fun to say.
It is.
So, Kelu, you're based in France, and this is how many? Is this your? No, this is not your first certified project. You certified a few projects before this, right?
That is correct. All of them are in the same field. That is around ultrasound imaging, and I think I have number 5 for France, which is one of the earlier iterations of this design. So I've been doing this. Maybe the first one is around 2017, 2018.
Okay. So yeah, let's talk about the PicoRic. Like, what exactly does the PicoRic do?
Nice cat. So
Let's be involved.
the PicoRic is actually the last iteration of an ambition to get the Arduino of ultrasound. So I'm a researcher by background, and I've studied ultrasound imaging when I was far younger. And there's been sort of a gap in what's on the market to get access to fast, quick, cheap ultrasound imaging. So the same way, that we have Arduino filling the gap for microcontrollers, then we needed to get something in for ultrasound. The main challenge has been that ultrasound imaging, the principle of that is doing pulse, echo, or catch and pitch imaging. So you throw a sound wave at something and you listen for reflections. These sound waves go in the megahertz, tens of megahertz frequencies. So that's definitely the sort of signals that you can't acquire using vanilla microcontrollers. So there's been a bit of exploration around how to do this type of fast acquisitions consistently and cheaply and in a simple way, because I'm by no means an electronic person nor a software person. And you also have some fun stuff around high voltages, because these sensors work with pulses around hundreds of volts that you send to them. So that's quite fast, quite high voltage, and you can have a lot of fun just having some magic smoke appear from time to time on your projects.
Amazing. So, what kind of guides your interest in ultrasound systems to begin with? How did you kind of get interested in that area?
So I started doing actual ultrasound in the industry in 2007, something like this, working in the US in the fantastic city of Seattle. I was working at the time on a low-cost device. Ultrasound machines are usually in the tens or hundreds of dollars, thousands of dollars. And there is definitely a way to look at old technology that had been made obsolete but can be rejuvenated using new electronic devices and components and chips and approaches. So what interests me in that is, on the one hand, ultrasound is an old technology. It has appeared in the 1920s, I think, for sonar uses. It's been developed in the 60s for medical use, and it's still being used today. And it's not only medical devices. It's when you want to test the quality of some welds, for example, you can use ultrasound. If you want to assess the state of materials, ultrasound. There are a lot of uses for ultrasound. And what's super interesting, I guess, is the open part as well. You've got a nice technology, you've got proven use cases, but all of the tech is usually closed, and there is today no open source equivalent of the devices and hardware, software that you can use to, for example, teach or to do your research. So what guides me, apart from the tech, is the fact that there is a big gap in the commons for ultrasound, and that is what this project aims at filling.
Yeah, that's really cool. Like, I feel like it doesn't surprise me that this is like probably the only project that's working in this area at this time. Like, I feel like a lot of people don't think about ultrasound technology very much and like what that looks like, especially not ways that you can make it more accessible and open. I mean, I personally have received medical ultrasounds, and to me, it's just like a weird device that you're there. They were using it to check my wrist to see if I had any buildup of I don't know, wrist problems. And I remember the guy like putting the gel on, and he was kind of fun about it. He was like, "Oh, like move this finger, and you can see like this tendon move in here and everything." But at the same time, it's a very mystical device to me. I don't even fully understand how they do what they do.
Right. Yeah. And there's this example, the tendon in the wrist is a super cool example, because when you talk about medical ultrasound, you think about having a look at someone's inside or organs.
Mm-hmm.
The other use you can have is, for example, for amputees, you can have prosthetics that detect these changes in tendons and muscles to actuate the prosthetics. So that is another fun use of ultrasound in a way that is not directly imaging. And there's been also a lot of research recently. So that's definitely an old technology, relatively old. But there's been so many new uses of the technology, for example, through compressed sensing, which is the equivalent of using a 1-pixel camera to do a 2D image, because you know the length of your camera. That has the potential to reduce the cost of ultrasound imaging by 100-fold. There's been new technologies in terms of sensors as well. So yeah, there is just so much we can do with ultrasound, and we can start with imaging the body, but we can do just so much more.
Definitely. When it comes to this project, do you see any more iterations or ways that you want to add to this, or are you thinking about approaching ultrasound from a completely different area? Or yeah, what are your thoughts on continuing this?
I guess it's the same point as Adam made, is you can take a lot on, and there will be just so many things to do. The field of possible is just so wide. I guess the main thing is to have a simple roadmap and a very limited, narrow approach, because as you lose all of the focus. So this iteration is already the continuation of a project over the course of the past, say, 10 years. And it has seen changes from first using a Raspberry Pi, then moving on to the use of an onboard FPGA, because we do need these fast speeds and parallel processing. And the Picoric, the main difference with its predecessor is the use of a Raspberry Pi Pico, because it has capabilities to some extent relatively similar to that of a FPGA at a fraction of the cost, with tool chains that are far easier to use. So today, the Picoric already by itself is the streamlining of the last 10 years of learning around ultrasound imaging. Now, the next steps, yeah, there are a couple, but I need first to think a bit more about what is feasible. What can be attractive, for example, is to use USB 3 to have super fast export of data, because when you do ultrasound imaging, you have transfers around the bandwidth of USB 3. So you're super limited by USB 2. So moving on to USB 3 might alleviate that issue. There are also opportunities around using software-defined radio to extract diagonal signals from your signal fast and efficiently. There would be much more also to do in terms of speed. Right now, we have seen the Raspberry Pico second iteration, the 2350, I think. And this chip is already, in terms of fast acquisitions, far better than the 2040. So there is also the possibility to use this next iteration to drive the next iteration of the Picoric. So I mean, yeah, there's just so much to do. What I'm trying to do at the moment is more supporting the users of the hardware and spending time with that community, trying to gather feedback also of their uses, because building something is nice, but once you've got some feedback of actual users, then that definitely gives you a different steer. And that gives you also, you've touched upon the importance of active contributors or maintainers. A project like this does need its fair share of contributors and maintainers. So spending a bit of time with the people inside the community can be also an area of focus.
Yeah, definitely. It's always like really important, like just like we were talking about with Adam, like making sure that there's folks that want to maintain and want to keep having this device exist. How have you found kind of people taking up the, like, is there a good community that is forming around folks that are using the Pico Rick, and how are they, what areas are you seeing it used in the most?
Some that's super niche, super geeky. So of course you reach the ultrasound geeks, which is a very narrow niche, and that's an advantage also. You can pull these people because you are the project that they will hear about. The community, what we see is mostly researchers, because when you don't have the money to invest tens of thousands of dollars in a piece of equipment, and you can have something around the hundreds, then you're super attracted. There is a bit around education. It's super easy to make a classroom experiment with one of the PICRICs. And the last niche I also see is the startups. You've got plenty of medtech startups which need, again, sort of a fast experimentation platform or an Arduino to try if the ideas that they have are actually feasible. So to de-risk and to do their proof of concepts, that they require a piece, and that's one of the things the PICRIC can do. So yeah, mostly researchers, and yeah, for the layperson, not super easy to go into ultrasound. Again, super geeky, but yeah, it's finding its own niche in the project's ecosystem.
Yeah, definitely. I mean, I feel like that's going to be a thing for almost every project. Like, you have to find the people that do care about this strange little device that you decided to put together, and you do find them, though. That's the thing. Like, I feel like for every project, there's always going to be, there's going to be the ultrasound geeks that want to know how it's working and how to put it together, and want to make one of their own and get to play with it in their own home, you know?
And that is one of the beauty of open source, I believe, is if you don't depend. In my case, that's a hobby. So in this case, I can spend all of the time I want. So you've got long timelines, and you're not depending on producing a product to live and earn money. So when you're into these timelines, you're developing step by step. You have the time to discuss with people, and we undervalue, as part of our projects, I feel, the expertise that we built on these long times. And now I can hold discussions with startups where I have a bit more experience than their CTOs in terms of this specific niche. So as part of this ecosystem, I do believe that we're building a wealth of experience in very niche topics. That is also super exciting.
Yeah, definitely. There was a comment that we had come in from actually our executive director, Kayla Jacob, who's watching the stream right now. And she said that ultrasound tech helps so many health/medical aspects. So important to have open source options for equity, transparency, and improved tech, which I think really speaks to a lot of the points you were making on, just open source creating that access that we don't see a lot of places.
Absolutely.
Beyond the Pico Rick, do you have any other projects that you're taking on or that you're interested in exploring, or is this your one and only right now?
There are parallel projects which are explorations around these new streams like the SDR or possibly the use of the new Pico, all in the place of ultrasound. Yeah, and that's already keeping me way too busy.
Yeah, that is the thing. We love to take on projects in the maker community.
Way too much.
I have my little shelf of abandoned projects behind me even, and also this cat that won't calm down. Well, is there any other things you'd like to point out when it comes to the Pico Rick or your work in general?
No, the main message, if I had one for this call, is just, the communities that we are building through these projects are, the one thing that I think brings the most value to the commons. It's not only the projects, it's all of the people, the users, the contributors, the maintainers, all of the ecosystem around us is the one thing that we help grow, and we should be proud of that.
Absolutely. Yeah. The things that people are making. I mean, one of the most exciting parts about working for OSHWA in general is getting to see just all the incredible things that people are making and the ways that people are working together to just, I mean, not to be lofty and whatnot, but I really do feel like open source changes the world, and these projects are how we get there, by people putting in the time and the care into making something that is so wonderful and giving it to the world. That's how we're going to do it. That's how we're going to fix this pile of mess.
Yeah, our contribution to this small change.
Exactly. Well, thank you so much for coming on today and giving us an overview of your project. I'm looking forward to seeing where that ends up and what comes next. I know that some folks working on our Open Healthware grant project have already taken a look at it and gotten some interest in figuring out more ways that they can find interactions between open source devices and the medical field. So I think we're going to see some really cool things coming out of that in the next couple of years.
Let's have these chats. Awesome.
Thank you so much, Luke.
Thank you, Sid. Ciao.
Okay. Really rad project. I also keep brain rot makes me go like Pico Rick, Pickle Rick. I'm not a Rick and Morty head. It's just, I do own a television. So next up, we're going to bring on a crew of folks joining us from the University of Canterbury. We've got Sam, Jacob, and Kayla, who have been working on a respiratory pressure and flow data collection device.
Hi.
Morning.
Good morning. How is 7 a.m. over there doing?
Very good.
Oh, yeah, great. Thank you.
Nice and early for y'all. Yeah, so let's talk a little bit about this device. So I will not lie. Overall, my knowledge of, well, this one specifically says framework for closed loop mechanical ventilation. Not my biggest area of knowledge. So I'm really interested to hear more about this. So how did this come to exist?
You go, Sam?
So yeah, sure. So this is about 3 or 4 years of honors project work at the University of Canterbury. So we're not the first group of people to have started developing something like this. So this device first came about from work from previous honors students at the University of Canterbury, working on making an open source ventilator and then making another open source respiratory sensor. But that sensor was for non-invasive mechanical ventilation. So essentially ventilation where you've got a mask over your mouth. So that might be on like a CPAP device, for example, if you've got sleep apnea. So the motivation for this is we wanted something that would work for invasive mechanical ventilation. So that's when you're in the ICU, you're sedated and there's a tube down your throat and it's doing all the breathing for you. So really the big motivator here was that currently in the ICU, the approach is very much currently, let's just see how someone's doing on a ventilator. Oh, they're doing great. Okay, let's change the settings a bit. Oh crap, they've gone blue. They're dying. Let's turn the settings back up. So it's not a very data-driven approach. So what we'd like to do in an academic sense is get all of that data, perform a bunch of analysis on it, and be able to predict how someone's going to respond to different ventilator settings based on, essentially just determine how someone's going to respond to different ventilator settings based on what they're currently doing. So this device that I've got here, oh, here's the camera, there we go. That allows us to gather data on patients without having to hack into any commercial ventilators, because it turns out that anyone who's making a commercial ventilator for the ICU really doesn't want you to get all of the data out, because that's what they've got over you, right? That's how they're going to make their money. That's how they're going to stay relevant.
I'm muted. Yeah, that's definitely like such a big aspect of ventilation. Like I know some folks who have done some work around ventilators, and folks who are actually looking at what it could be like to turn CPAP machines that are considerably cheaper than ventilators found in hospitals into seeing if that was possible. And they got a real big "stop doing that" letter. So there is definitely a lot of companies that would really love to hold on to that data and keep it for themselves, which is so interesting. But I guess we live in a capitalist world, so that's what happens. So your group, y'all started getting involved on a project that already existed, or the some of the research was already there and it kind of drew you in?
Do you want me to take this one, Jacob and Kayla?
Oh, I'll do it. Yep. So previously, so like Sam said, there's last year was the ventilator, which is the MEPAT. That is just a positive airway pressure device that we are able to use for our project. It also is fully controllable over Bluetooth, so it helps us close the loop, which I can explain more about that later if you want. And then again, we have developed on the non-invasive device, which is just used with an orofacial mask. So I can show you, I'll just share my screen if that helps. I can explain the closed loop side of it a little bit more.
That would be wonderful, because that is also a thing that I don't really get. So this is perfect.
Can you see that?
Sure can.
Oh.
Okay. So can you see my mouse as well?
Yep.
Cool. So this is effectively what we mean by closed loop control. So the ventilator is connected to the patient and supplying air support. And then we have our sensor system in series with this connection, and that's measuring pressure data. And then that data is sent to a digital bedside sheet, which it's where the data is converted to flow and integrated with a digital twin model. The digital twin model is just like a mathematical model that will analyze the patient data, and then based on a parameter that we are looking at reducing or optimizing, it can then find the best ventilator setting. And then the best ventilator setting that we decide, that is decided from the digital twin model, is then sent back to the ventilator, and then it'll update all automatically and can fully automate the care. And so looking at this is sort of how we've been doing our testing. The ventilator is the MEPAT, which I just described, that was designed last year. So that's fully adjustable over Bluetooth. And this is our sensor system in line with a mechanical lung, which is simulating the patient. So our sensor system's measuring the pressure data, sending it via Bluetooth to the portable digital bedside sheet, which is the laptop. And then that's all the processing is done in the laptop, and then can send commands back to the ventilator via Bluetooth as well.
Amazing. So what this is such a goofy question, but so what are y'all in school for that this is what you end up working on? Like, this is such a fun project to be working on. What are you studying?
Interestingly, we're actually all engineers, mechanical engineering students.
Yep.
Oh, Sam's mechatronics
Whoa.
engineering.
Yeah.
So we're minoring in biomedical engineering, and we're working in the bioengineering research group at the University of Canterbury, which is one of their focuses on mechanical ventilation, which is kind of how this
Incredible.
came about.
So did you have much passion for this aspect of biomedical engineering going into school, or was this just something that you ended up finding interest in while you were there?
Specifically ventilation, more kind of while at school, but the general bioengineering I've been interested in for a while.
Mm-hmm.
Yeah, it's about the same with me. Just always had like an interest in how medical devices worked, and it was quite cool to be able to do this project as well, to sort of make my own, which is cool.
Yeah, very, very similar experience for me. My take on it is that if you're going to do something like engineering where you could spend your entire career making something, I think biomedical engineering is a really good way to spend your career making something useful. It's like you see lots of people like going off to work for big contractors and like they're making missiles or something. Like, I'd rather be doing something a bit nicer with my engineering knowledge. So that's my take.
Yeah, definitely. That's increasingly a thing that I think we're all kind of thinking about, of the ways that, like, you know, we're the ones making the thing, so why are we making something we hate? Yeah, so do you mind actually showing the device a little bit more, and kind of, I know you have a version
sure.
with you. Yeah.
I'm just gonna try to get it on the camera. There we go. Yeah, so this is the device. Currently it's being all the guts of it's being held in by this 3D printed case. But how it works in terms of the setup is you'd either have a mechanical lung or even a patient if you made this out of something that's more biocompatible. So if I go like that, there we go. You'd have the center of your mouth and an intake tubing coming in this way and outtake going this way. And within the device, there's a pressure sensor. You can't really see that here at my mouth, but there's one on either side as well. So you essentially get the pressure at my mouth at all times, but you also get the pressure for when I'm breathing in and the pressure from when I'm breathing out. And it turns out that that's all data that you need to reconstruct all of the breath profiles, so flow and volume as well as pressure that they use in the ICU. So that allows us to do pretty much everything.
Inside there's 2 venturis, so that's where we're measuring the flow. There's differential pressure sensors across the inhalatory and exhalatory flow, and then that just gets combined to get a complete flow profile.
Should we show the inside of it? We've got a...
Oh yeah, I would love to see the inside.
Yeah, photos would be nice.
We've got a picture of it, if I can figure out how to share my screen.
I can do it, that's right.
Okay. Thank you.
We actually used this service specifically to torture Jacob, who also had some technical difficulties getting set up today. So
yeah, my internet dropped out 3 times.
Oh no.
Oh no, apparently I cannot share that window anymore.
I think we have to redo this, the present, and then I can put it back on screen.
If you want, I could also just unscrew this one.
I think I've done it.
I think Jacob's got it.
Oh. Perfect. I don't have to take everything apart.
Yeah, okay. So
Oh, awesome.
We've just got a picture of it with the lid off, basically. So at that patient end, you've got a Y piece splitting the flow into the inhalatory and exhalatory side. And inside those little bands there, we've got these little one-way valves, which we adapted and made internal. So they just slot inside the venturi and the Y piece. So that prevents the flow from going the wrong way when you're breathing. So you get all the inhalatory pressure going through the inhalatory sensors and all the exhalatory going through the exhalatory venturi. So we get the right flow measurements when you're breathing. And yeah, we can see the sensors here. They're all differential pressure sensors, but the one at the Y piece is just vented to atmosphere, so it's measuring the gauge pressure. And yeah, that's all just connected to an ESP32 board, which we've got running in Bluetooth, connecting to the computer and ventilator.
Perfect. I mean, it's really like that beauty of like a simple design can really do everything you need it to do. And I love that it's like really straightforward. It's not complicated. It's really the internal pieces. It's 3 pieces and a board, and that is all you need to make this happen. That's amazing. And then going forward, are you planning on doing some more work on this sensor? Are you wanting to do others, or are you starting to move away from respiratory pressure on a whole and experiment with some new ideas?
You take that one, Sam.
Yeah, I think I'm the most relevant one to take that. So for the next 3 years or so, I'm going to be still at the University of Canterbury doing my PhD. It's quite similar to what we're doing here in the fact that instead of looking at making a device for data collection, I'm going to be doing research on developing new mathematical models to optimize care based on the stuff that we measured. So I think the answers I see in the private chat, Adam's been asking, whether this is something that's to be picked up by other researchers or hospitals. Yeah, so this body of work's gonna keep on being developed here at UC. So I think I want to say in total there's about 10 doctoral candidates, postdocs, professors, all involved in this project. So there's a large group of people working on maintaining this and getting the modeling side of things up and running. On top of that, I believe that UC has partnerships in Belgium, for example, in Liège. So there's room for collaboration there.
Incredible. So have you what is the process around that in New Zealand specifically about getting it into the hands of hospital workers and providers? Have you been able to do that yet, or are we still in the trying to get it out there phase?
Yeah, still in the trying to get it out there phase. So there's a lot of clinical trials required. So the first step would be doing clinical trials here at the university. So one of the other devices that's being certified by OSHWA from UC is a device that simulates, I think it's COPD, which is a respiratory disease. So the first step would be getting this device, plugging it up with healthy patients, as well as the device that simulates lung disease, and then seeing whether we can get good data there and whether we can optimize care there. Once that's done, we can test more models on that again at UC through clinical trials. So then after a few rounds of clinical trials, then we'll be thinking about running a trial in a hospital, probably in Christchurch to start with.
Makes sense. Yeah, I get as we venture into the medical field ourselves, we're really, I mean, I know that all these trials make sense. We want to make sure we're giving people the safest possible devices, but it is a long haul to get involved in designing.
Exactly. Yeah, and I mean, relative to the US, even New Zealand's like a relatively easy place to have a device break out into. So I imagine getting a device like this overseas into the US market, for example, would be even more trials. But it's just what you got to do, right?
Well, who knows? Maybe they're just going to give up on any kind of regulation. They're on their way there, you know. I'm not. It's also US, so I'm allowed to say that.
It's also currently just 3D printed out of PLA, so we'd also need to print it in a biocompatible resin. But that's like easy enough. We've all sort of designed our CAD model around that. So yeah, need a few changes like that as well with the design for full certification.
Yeah. Okay, so we're coming up on the last little bit. Is there anything else y'all would like to add about your project or what you see yourselves working on next individually or as a group?
I think that's all. Yeah, thank you.
Yeah. Totally
Yeah.
valid. Okay. Thank you so much for coming out today and giving us an overview of the device. And I feel like I know a whole lot more about how respiratory pressure works now, which is going to
Awesome.
be great if we see more of these projects coming in. I feel like
Yeah.
I'm more prepared.
That's what we want.
Yeah, awesome stuff.
Thank you so much, folks.
Thank you.
Okay, wow. Okay, that was a lot of information from a lot of really rad creators, and all of it was really cool information. So I hope you enjoyed getting to know a little bit about some of our projects that got certified in October for Open Hardware Month. And we're going to be back again next month. Like I said, this is now a monthly situation. So our next one will be in December on December 19th. 1 p.m. EST again, and looking forward to finding out more and more about people's projects and the things that we're seeing created in the open source community. Have a good day, y'all.